ladies and gentlemen. Let's talk about electronics. Okay. Remember, do not have a plumber to work on your car. All right. Now, we are network guys. Okay. But if I really wanted to know how a T1 line works, I'm not going to my engineer, my network engineer. Sorry, not going to do it. I'm going to the PBX guy. Okay? He's the one I'm going to talk to about T1 trunk lines coming in and how they work and synchronization and putting the actual information on the wire. Okay? That's who I'm going to talk to. All right? Because their understanding needs to be deeper than our understanding. Okay? Because our concept of a T1 line, okay, whatever line was coming in, that's the ISP's problem. Okay? I don't care. All right, I know what I need to know to do my job, and that's about as deep as I go. Okay, and for extra activity, if I'm sitting there bored at work, yeah, I might do some reading on T1 lines. Okay, but all right, it's arbitrary. It's just something to do to pass the time. Okay, and it's really now don't get me wrong. Okay, I can't tell you how many times, okay, doing that arbitrary action or aspect, okay, uh, give, years later, I'll be like, I remember reading something about this particular scenario and go back and recall something I did 5 years ago as far as a means of just passing time. Okay? Don't get it twisted. All right? I can't tell you how many times I read something in a book that morning and I ended up coming up with the same problem I read, okay? And I'm telling you, all right, even though I've lacked off my reading, okay, this is a necessity. You want to be good at your job, okay? All right, some people have motivations. Some want to be the top 1%, okay? I'm not trying to be the smartest guy in the room because let me tell you, all right, in my philosophy, when I'm the smartest guy in the room, it's time to find a new room. And I shit you not. All right? And I'm not kidding. Never stop learning. Okay? All right? I like in my life to be the change in the world I want to see. I will never forget that day when I saw that message or that quote from Gandhi on somebody's wall. I had no idea it was a Gandhi quote either. Okay? All right? Ever since that day, that's how I lived my life. Which I was living my life anyway like that. It just never really came into perspective. Okay? At 10 years old, I made rules of life. I mean, my three rules of life. Okay? All right? And I've never, ever, ever derailed from it. Okay? Number one, always respect women. I was raised by women, so hey. Okay? Number two, okay? Always control your emotions, even when they're out of control. Number two, okay? Never forget rule number one and two. And the fourth one that I added after a while was never interfere with someone's timeline in a negative fashion. I would rather say nothing than to give you advice that has a negative aspect or the potential of a negative aspect. And I'll just tell you flat out, I don't know. Okay? And these are my rules of life, my philosophy that I follow, not somebody else's. Okay? All right? I want to produce, create, innovate on a higher level. Okay? And like Karos once says, I'll be back, but for now, just settle. All right? If you don't know what that word means, it means to settle. Okay? Calm down. Relax. Chill out. Take a thought. Take a breather. Okay? This is your life. It's yours. Not anybody else's. Okay? You have the power to do whatever you want. You could go into the interview, okay, and just don't give a shit. You'd be surprised how much easier and relaxed you are in that interview. Now you give a shit, okay? All right? Because you showed up on time. You're answering the questions. Your personality is who you are. You're just being you. So you give a shit, but you don't care about their motivation as far as the concept of this is what we're trying to accomplish, because you are looking for someone that is accomplishing A while they're accomplishing B. So when you're sitting there in that interview, you have no worries and no caring about saying, I don't know, I don't know that technology. You don't try to bullshit your way through it. You don't try to lie about the concepts, okay? Because you don't know what you don't know. And the bottom line is what? They're going, they know that, all right, you know, some things you cannot fake, okay? All right, and trying to fake, and the concept of you saying I don't know, okay, and being honest, that in itself, and you just being who you are, they pick up on that, and that in itself is a huge selling point from their perspective, okay? Now, everything has a philosophy in it, okay, in my world, and everything has a deeper meaning in my world. It's not just the technology that we're learning, it's the question of why, okay? Keras One, which is my favorite rapper back in the day, okay, stands for knowledge remains supreme over nearly everyone, okay? All right? Now, are you going to produce, create, and innovate on a higher level? So let me give you the tools to do that. And those tools are going to be talking about electronics. Now, you are a network engineer. I'm going to set a scenario for you. You go to work, okay? You know Cisco commands left and right, all right? Okay, I've been in interviews where I've been told that I am uh, uh, um, you know, because I got every question right on the questions they were answering me, I was book smart. And oh my God, saying that Kyle Martin is book smart from the perspective that all he does is read and memorize information, you've got to be kidding me. Okay, math was my subject when I was in high school and grade school. English, I got straight E's and F's. Okay, especially history. Don't even get me started on that. All right, there is no book smarts. All right, period. Okay, give me. All right, and I just say this. I said, you bring me routers and switches out of your depot right now. Okay, create a lab, and I'll do that lab. All right. Jesus, when I was actually in ITT, the actual college, not ITT, the ones that actually take all your money and put you in debt for, multiple decades. All right. Our last assignment of the networking course as I was going through my degree, okay, which I never finished, by the way, because the certifications were so much more powerful than when I was learning there. Plus, they were biased against networking. Okay, that's where I started my CCNA club, my Cisco club. Sorry. All right, where we would get together once a week. All right, use one of their classrooms, and we would talk about Cisco. And I would actually go through CCNA topics. All right, that is where. That's how I started. All right. Now, our last assignment, she gave the class, okay, and I'm a CCNA at this point, okay. I actually was still going through advanced routing on the CCNP, I believe, or no, I was probably going through switching because I did switching first, all right, and I did advanced routing second, all right. Now, and I did troubleshooting last. So now keep in mind at that point in time, I hadn't gotten past the advanced routing and switching, so they were still on a 4 exam track. Okay, so yeah, you can hear I'm getting kind of winded. So, but nonetheless, but during that time also, that's when they changed it to a three exam track. So, I was, I believe it was through that period. But the assignment, okay, I kid you not, man. In the beginning, she gave us our final project, which was going to be 75% of our grade. Okay. All right. And it was a lab. It was a Cisco lab. Okay. Using Packet Tracer as a means of actually doing the work. All right. And, it had it had things on there where you got to set up a DHCP server and you got to have a default gateway for the traffic. Okay. Make sure that the traffic is being sent this way because you got multiple paths for the actual traffic to go for this network, and for this network it has to take this, this path, blah 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 blah. You got to set up a running protocol. Okay, your static routes have to be floating, things like that. Okay, it was a pretty cool lab. All right, and it was actually written out in the book. Okay, and you could tell they took that lab from from somewhere. Um, and put it in their books. But the cool thing is, and I shit you not, that moment, okay, while she was teaching the subject of the day, I completed that lab that they gave us over a week to accomplish as our final grade. It got every answer correct because it was just that simple to me. And it's not because I am book smart, and it's not because I'm the smartest person on the planet. It is because I fucking study. And everything that we do in our field has multiple blankets of levels, and one of those levels is electricity, electronics. Okay? Without electricity, we can't be the people that we are. Okay? Without Steve Jobs, we can't be the people that we are. Okay? Without Bill Gates, regardless of how you personally feel about him, all right, that's irrelevant. All right? Without Thomas Edison, we can't be the people that we are. All right? So let me help you get to that level. But you got to accept the information. Now, electronics is what we use to do our job. Okay? And I want to first start off with the concept of what a processor does. The processor is what is used as a means of transistors. Okay? The concept of a transistor is having a path or a choice that is able to be given based on the software or the programming that is given in the software to tell the hardware which path to take. Okay? All right? What is AI? Why is AI so so the topic? All right, we've had guys, and I can't stand this because AI has been around for God knows how long. Okay, AI. I mean, my buddy and I used to have discussions about AI back in the '90s. Okay, and I mean like the early '90s. Okay, so but the concept of AI, okay, is the concept of a PC only does what you tell it to do. A electronic device only does what it tells you to do. It only makes choices, either a one or a zero. That's their language. Okay? However, if you're able to have a machine, okay, take information that it has acquired around it, all right, and create new code or new um, decisions to be made, okay, that is what we do. We call those choices, all right? And you cannot put a interface on a VLAN without changing a 1 or a 0, okay, for that port to be in that VLAN. And you can't do this without an electronic circuit board. You can't do this without electricity. And since I'm going to talk to the phone guy about T1 lines, I'm never in my life, whether I'm an ex-electrician or not, because I am, never am I going to argue about how electricity works with someone who is an electronic major. I'm just, dude, it's just asking for embarrassment. All right. This is where it comes down to knowledge of what you're dealing with. Okay. Why do we need to know this? Well, your job as an engineer is to design. Well, guess what? You only have so much power coming into the building, and you got to make sure that your devices are in the power requirements, okay? And you got to make sure that you're not overloading a circuit. So what is a circuit? A circuit is nothing more than a pathway. I want you to think about a circuit just like I use networking as far as roads and cars and people are concerned. We're going to do the same thing. A circuit is a path. The road coming from your house to my house across the street is a circuit, is a path to get from one point to another. Okay? Our paths in electricity is called circuits. Okay? And as a transistor would take the voltage going in one path, and once that 0 turns into a 1, that transistor is going to change that path from path A and bring the voltage over to path B. Okay? And your processor has trillions of transistors. Okay? This is how it has its power. That's why it communicates on a particular certain frequency. How fast can it move that data through the transistors and make choices and change their decisions when the software is telling it to do so. Okay? So our paths from those circuits are done by conductive wiring. Aluminum, copper, gold, platinum, you get the idea. Okay? That is how our electricity is carried from one place to another. Just like our electrical signals coming out of the interface, we're using copper wire to move that electricity. The case, how does our electricity flow through the wire? All right. Well, before we talk about that, how is electricity created? Well, it's actually come from the power company. There's lots of physics and fusion involved. And no. Wrong. All you do, guys, is take a copper wire, okay? All right? Let's say it's 1 foot in length, all right? Okay, it doesn't really matter. All right, and you take a magnet, okay, and run it across the wire, and the magnetic field of that magnet will move the electrons in the atoms of that wire, and you now have electricity. Now, I can't run the magnet up and down parallel with the wire. It has to be in the opposite direction. There's some kind of theory that, depending on which direction the magnetic field is going, okay, depends on which direction the electrons are going. Okay, so you got to go across the wire perpendicular, okay, or in a plus or X faction to make the electrons move in the opposite direction coming out the wire. All right, hook a voltmeter to that wire and you will see voltage. Now, you do this and you're like, Kyle's full of shit. All right, it doesn't work. Well, you don't have enough electrons for the voltmeter to read any voltage. So what do? Loop the wire over and over and over and over and over in a circular motion, okay, and then try it then. Now you know why we have coils or wrapped wire around transformers and inverters and things like that, okay, or electricity in general. That's how you create electricity. There's no fusion or some magical thing going on, all right? It's just magnetism, all right? And this is amazing. Whoever discovered this is a freaking genius, okay? All right. Somewhere down the line, a magnet moved across the wire and he got shocked. And he was like, what the hell just happened? Right? So, how do we move the electrons in a way where I can provide enough power to actually run the stuff that I need to run? Okay. And how do I do it over a period of distance? Well, this will actually be your measurement of volts. Okay, now volts is just a unit of measurement. Okay, voltage is what is in on the wire moving the electrons. Think of it as water pressure. Okay, if I want those electrons, okay, to move 100 feet down the road, okay, I'm going to up the voltage, which literally makes the electrons move faster, pushing the electrons in front of them down the wire, and I have voltage. Okay, that's what voltage means. Okay, amperage. Amperage is the concept of, okay, or ampere, sorry, I call it amperage. All right, is the concept of what load is on the wire in that given moment. Okay, that's why we use amp clamps to hover over the wire, okay, or to clamp over the wire, all right, to get an amp reading. Amperage is crucial because the thickness of the wire determines how much amperage a wire can hold. And when a device is within that circuit, because that's what all we're doing is we're putting a device in the middle of that circuit, and that electricity flows through the circuit, goes through the device, and the device is powered. That powering device is now causing a load on the wire. Okay? All right? It's just like having a scale and putting weights on it. The more weights we have, the farther the scale would tip. Okay? With amperage, the more load or devices or amperage on the wire, okay, the more friction is created as that electricity goes down the wire, and that friction causes heat. Too much amperage, too much friction, your wire will not be able to handle it, and the heat will disintegrate that wire. Okay? And then if that wire is wrapped around with a plastic casing in the wire itself, and that plastic case and those wires with the plastic casing is wrapped around with just rubber, okay, a rubber jacket, all right, what's going to happen when that rubber gets heated? Once the wire starts to heat up that hot, it's going to catch on fire. All right? That's why we have breakers. When the amperage for a wire, okay, all right, okay, so everything is done by the wire itself. If I run, which is called gauge wire, okay, if I run 14 gauge wire, okay, that wire is certified up to 15 amperage, okay? Now, don't you dare take that 14 gauge wire and put a 20 amp breaker on it. Don't you dare. You better not have anything more than 15 amps, Now you can put a 10 amp on there. I mean, a 10 amp breaker. You can put a 1 amp breaker. All depends on how you want that circuit, okay, to be monitored. But don't you dare go higher than the certified or rated amperage of that wire. All right. The concept of a breaker is when it hits 15 amps, okay, it'll still run on that circuit. That breaker will still be turned on or operational. The moment it gets to 16 amps, it's going to shut off. It's going to trip. Now, that's in theory, okay? I mean, at some point it could go all the way up to 20 amps before it trips. All right, but you get the idea. All right? The breaker has nothing to do with protecting your devices at all. That is not why we use breakers. We use breakers to kill the possibility of that wire being over amperaged and burning up, breaking the circuit, starting fires, so on and so on. I want you to think about an electrical fire within the wall. Okay, my grandfather used to do this all the time, and boy, was he an idiot. Okay, one thing that my grandfather always taught me is what not to do. Okay, giving me the concept that not knowing the wrong way is just as important as knowing the right way. Okay, constantly my grandfather, okay, which ended up me having the bad habit as well before I became an electrician, realizing why we have these amp ratings. He would always, because they had circular fuses that you had to screw in into the panel. Okay, it wasn't a breaker. So we had to buy fuses. And every time that fuse would break, he would get tired of having to go downstairs and replace the fuse. And it's still of recognizing how electricity works and why the fuse was breaking. Okay, he taught me just to add an extra 5 amp breaker or a higher breaker in there to stop it from tripping. That puts your family, your life, and yourself in death danger. Because when that fire, okay, now the reason why this never happened in my grandparents' house, because their electrical wiring was wrapped around not with rubber but a metal jacket. And the thing about a metal jacket is once that wire gets so heated, okay, and breaks or burns or starts to burn up the actual plastic jacket around it, all right, it's going to eventually become naked and touch the side of the actual metal steel jacket, shorting out the circuit, killing the fuse, okay, stopping the fire. That's the only reason. If he had normal Romex or normal wiring that we put in residentials today, all of us would be dead. I would have never seen the age of 12, maybe even younger. He would have killed his whole family. And I'm not kidding. Thank the Lord. His entire house was done with steel jacket, okay, or MC cable, if you want to call it that. Well, MC cable is the metal jacket with a ground, but still, I'm an ex-electrician, so these terms you don't, it'd be nice to know them, okay, because you got different types of wiring, and you got different types of thickness, and you got different types of reasons why you use that wire. Okay, so now, don't ever know what your wiring is, know your gauge, okay, which is going to be written on the jacket of the actual wiring, so you can easily find out if it's 14 gauge, okay, 15 gauge, 14 gauge, 10 gauge, 8 gauge, whatever, okay. The lower the number of gauge, the thicker the wire is. All right. Now, watts is the measure of power consumption. Okay, everyone has heard the term kilowatts, right, on your electric bill. Okay, and all kilowatts is, because 1 watts Look at the number of how many kilowatts that is. We're in the thousands place, right? Past the decimal point, you get the 10th place, the 100th place, and the 1,000th place. Okay? It takes 1,000 watts to equal 1 kilowatt. And 1 watt equals 0.001 kilowatts. Okay? And 1 kilowatts will equal 4.5 amps. So if you're running a kilowatt per hour, okay, all that's telling you is how much kilowatts that energy is using in an hour. Okay? If I'm using 1 kilowatt per hour, okay, that means within an hour's time, I would have consumed 1 kilowatt. All right? Does that make sense? That's all it is. All right? And it's just an annoyance means of measurement, just like Fahrenheit and Celsius, okay? All right? Nothing's more annoying because I know how hot 100 degrees is. I have no idea how hot 100 degrees is in 100 degrees Fahrenheit. I don't know what 100 degrees Celsius is because I don't use Celsius. All right, I can convert that measurement from Fahrenheit to Celsius, but why would I? I have no need. I have no need for it. That's the beauty of it. I don't have to. Okay. All right. Kelvin. Kelvin's also another means of measurement. Okay. It's just nothing more than annoyance. Some person decided to use kilowatts per hour when all the devices that we purchase are measured in watts. Someone decided I'm going to use kilowatts, okay, for whatever reason. Don't know, don't care. Now, okay, all this is related, by the way. Your voltage, your amperage, your watts, okay, and 1 amp is equal to X a number of voltage, of watts based on the voltage. I don't know if it's watts or something else. 1 amp equals, I should have been more specific on that. Okay, but still, this is based on your voltage. Coming into your residential house, okay, your power most of the time is going to be up to 240 volts, okay? Meaning that you can have 240 volt circuits or you can have 120 volt circuits, all right? The concept of a joule is just a measurement of energy, okay? This has to do with Newton's law, and it's over a meter of distance. All right. Now, remember that fire I was telling you about? This is where resistance comes into place. Okay. Think of resistance as if, okay, an elevator falls and you, the superhero, gets underneath the elevator, okay, you fly up, and you catch the elevator and you slow it down to save the people inside. That slowing down the elevator is you as a superhero pushing your energy and your pressure against the actual falling object to slow it down, to bring it to a halt. That is the resistance you are providing for that particular falling elevator. That is what resistance is. Holding back the electrons, having them build up, okay? And these electrons are vibrating, they're moving, okay? And when you are creating a sense of resistance, you're holding back the flow of electricity on that wire. That creates heat, okay? All right? If I take a hair dryer and heat up the wire, okay, on that actual electrical circuit, okay, that also slows down the electrons. All right, so they're related. All right, the measurement of resistance we use the term ohms. And on your voltmeter, which you should never be working electricity ever, or playing with electricity or any type of circuits without a voltmeter, that'll allow you to test DC current, AC current, okay, and resistance on your circuit. Now, your coulomb, or however you say it, okay, this is a measurement of charging. So if you want to know, okay, how to charge your phone and want to be able to charge your phone and do it many charges, get something with a higher coulomb or milliamps, because that is telling you how much charging it's able to give you. Okay? Now, that means we need to understand which direction electricity goes. Electricity at one point in time, especially back in my day, all right, was known that the power flows from a positive charge to a negative charge. And the reason why we thought that was because electricity always takes the path of least resistance to ground. What is ground? Ground is nothing more than the earth itself, the ground. When lightning strikes, that's why it comes to the ground. It wants to hit ground, okay? Those positive charges and negative charges are attracted. So if I have a positive charge, it is so attracted to a negative charge. It's like a magnet. Opposite poles attract, right? Okay, same concept. All right, when lightning strikes, okay, if there's a path to ground, it will take it. And it will take it instantly before taking any other path. Especially now, if it has multiple paths to ground, it's going to take the one of least resistance. Okay? What is also resistance on a circuit? A light bulb, your switch, your router. Okay? You have now put resistance on that circuit. You now have a load on that circuit based on how much it is consuming. Okay? It's not the voltage that kills you, it's the amperage. And that's so much bullshit I can't even tell you. I can't even tell you. Okay? All right? Because the bottom line is, when you get shocked by 120 volts, all right, it's annoying as shit. All right? It doesn't feel good, but it's more of an annoyance than it is pain. All right? You go into a commercial building, okay, the next higher voltage is not 240 volts, it's 277. And that shit hurts. Okay? I can have the same amperage, okay, on 277 and on 120, okay, and the difference is going to be astronomical because 277 kills. Do you want to have any idea how much voltage that we're using on those lights in the parking lot? 480 volts. Can you imagine being shocked by that? I guarantee you, even though you have no problem hooking up an electrical receptacle or light switch when the power is on in a house of 120 volts, I bet you won't do it in a parking lot with a parking light, a pole light with a 480 volts. I bet you won't do it then. So don't don't think that voltage can't kill you. It's the amperage. This is a crock of shit. All right. Okay, these were terms back in the day that electrician mechanics would actually educate you as a electrician helper, and that's just not the case. All right, the more you learn about electricity, you start to realize how much respect you need to give this physical, or I should say physics anomaly. All right. Now, hertz. Hertz is the definition of a hertz. A hertz is cycles per second. Now, your processor runs at a certain hertz or a certain frequency. Okay? All right? The frequencies is the hertz. So if I'm running at 100 hertz, okay? All right? That means within 1 second, I'm able to do 100 processing moments, okay, or 100 processing cycles, because every process is a cycle, okay, from a CPU's perspective. So 100 hertz, I can do 100 cycles or 100 processing moments, okay, in 1 second. It's cycles per second. All right? If I have a gigahertz, guess what? Times that by 10. Right? Does that make sense? So, now, it's the same concept as radio signals, as we talk about the frequency of the radio signal, right? Okay, the higher the actual number on your radio band, you know, the easier it is to bring that signal to me, the clearer it might be, the quality might be a little bit better, okay, but that's based on other technologies that we're not going to get involved in. And again, don't quote me because I'm not a radio guy as far as radio frequencies are concerned. All right, so now you start off with your wire. You find out what your wiring is rated for by amps. You run that circuit by just running a wire to a box, okay, in your wall, and then you run the other side to your electrical panel, all right, and it's 14 gauge, 15 amp reading, and now what do? Okay, all right, you put a 15 amp break on there. Now, here's the important aspect, my friends, okay, a circuit, regardless of how many devices you have on that circuit, you are creating a load and resistance. Okay, you run 15 gauge wire, giving you 20 amps, and you put a 20 amp breaker on there, and you go out and you buy the cheapest receptacle you can. But what you did not do and you did not read was the fact that that receptacle is only rated at 15 amps, and you did not spend the extra money to get a 20 amp receptacle because you're ignorant. You just don't know. Okay, and I'm gonna tell you what's going to happen, and it has happened to me. You turn on your AC, and because that receptacle at 15 amps is running on a 20 gauge wire on a 20 I'm sorry, not 20 gauge, whatever, a 15 gauge wire with a 20 amp breaker, what's going to happen is the heat on that receptacle is going to start to increase because of the fact that you have put a load of 20 amps on a 15 amp capacity, and that in the middle of your circuit is what's going to happen is that receptacle is going to get so hot it's going to glow like a light bulb, and I'm not kidding. What do you think a light bulb is? It's just a piece of metal coming from in between positive and negative, okay? And the resistance of that small tiny wire, it can't handle the actual resistance or the heat, so it glows. That's how we get light bulbs. That's how we get light. Okay? You're heating that wire between those two terminals. Take a look at the light bulb. Really look into it. You'll see two rabbit ear type antennas, okay, inside the light bulb, and a thin coil wire that wraps around. How do you think a hairdryer works? Okay? A hairdryer works by heating up a piece of wire, okay, or several wires, and blowing air across it. Have you ever taken a hairdryer apart and turned it on without the fan? Disconnected the fan. I have, because that was my, you know, thing that I did when I was a kid, and I got in lots of trouble for messing things up in the house because I took things apart. Okay, and when my mom didn't know, all right, because I'm talking low so she doesn't hear me, but what my mom doesn't know is she could never understand back in the day when I was a kid why her hair dryers stopped working all the time, and all of a sudden she would shake them and it'd be, all these moving parts, okay, like a penny was inside the hair dryer. She thought this was a manufacturer defect, but no, it was me taking apart, and I was great at taking things apart, but holy shit, did I suck putting them back together. All right, you know those projects you did taking something apart and there's always screws left over. Oh my god, the screws that I would have left over would be astronomical. All right, then I got into a way of systematically, okay, putting things in a certain spot to put them together. The coolest thing I've ever seen, okay, which I am still today incapable of doing, is watching one of my acquaintances back in the day take apart a BB gun. And when I mean parts, oh my God, they were all over the floor. And when I went to go pick something up, he flipped out. You move one part, man, I'll never be able to put it back together. I don't know how his brain worked in that fashion, but he was capable of doing that. He was capable of opening it up and reversing the engineering concept of putting it back together. I can't do that. Okay, not with that many parts. And when I mean a lot of parts, man, it was, like I said, all over the floor. It was crazy. All right. Now, we've learned some pretty awesome things. Okay, so I'm gonna stop the video now. All right, this is the basic concepts of understanding electricity and how your stuff is working. And I will see you on the next video. And always remember, be strong, be determined, be Cisco.